Hello, 7th graders. We're in section 3.9, which covers the Pythagorean theorem. Now, this is something that you covered last year, but we're going to add more to it this year with more extensions. So let's quickly review what the Pythagorean theorem is and what it's used for. As you can see here on the right, I have drawn a right triangle. It is imperative that you understand that this must be a right triangle. If you are not given that this is a right angle, then you absolutely cannot use or assume that it is a right triangle, therefore you cannot use the Pythagorean theorem. The two legs are letters A and B. A and B form the 90-degree angle. So if I ask you on a test, how do you know which sides the legs are? You have to say the two sides that form the 90 degrees. The side that's across from the 90 degrees is your longest side, which is represented by the letter C, and it's called the hypotenuse. What's the purpose of the Pythagorean theorem? Well, the purpose of the Pythagorean theorem is to find one of the missing sides of a right triangle. So the Pythagorean theorem, as you already know, is represented by the square of the legs, the sum of them, which is equal to the square of the hypotenuse. A squared plus B squared equals C squared. So let's start with A. In A, we have a right triangle. And I did not mean to actually draw that circle. So yeah, just ignore that. So we have a right triangle. If we use the Pythagorean theorem, A squared plus B squared equals C squared. The two sides that form our 90-degree angles are our legs, which are going to be A and B. So it doesn't matter where you plug them in, as long as you plug them in for A and B. So I'm going to say 3/10 squared plus 2/5 squared equals C squared. 3/10 squared would give me 9/100ths, plus 2/5 squared gives me 4/25ths equals C squared. We now have to find the sum of our two fractions. 4/25ths would give me, if I had a common denominator of 100, that would give me 16/100ths. 900ths plus 16/100ths would give me 25/100ths equals C squared. Now, you can simplify 25/100ths into 1/4. You can do that. Or, the opposite of squaring something is the squared root. So you have to take the squared root of both sides, which would give me 5/10, and that would give me an answer of 1/2. But remember, you have to be precise. My answer, then, would be 1/2 inch, and that would be the representation of the longest side, which is C. In the next example, we have 9 and 15 centimeters. The two sides that form my 90 degrees, those are the legs. So one of the legs we don't know. So I'm going to leave A squared alone and plug in 9 for B and 15 for C. So we take A squared plus 81 equals 225. I then have to subtract 81 on both sides because we have to isolate the variable. So if you subtract it from both sides, you would get 144. You then take the square root of both sides, and your answer will be 12, and we have to label. It would be 12 centimeters. Example 2 is on page 182. So let's read it together. A 10-foot fire truck parks beside a building such that the base of the ladder is 16 foot from the building. The fire truck extends the ladder 30 feet. How high is the top of the ladder above the ground? Now, when we look at this, you'll notice that there's no picture. The problem is that it's hard to visualize this or solve this without a picture. So do the best you can at drawing your own picture. So, I'm going to draw a fire truck. Now, this is going to be a really bad picture. So here's my fire truck. There it is. There's my fire. I'll color it red. That will help. There we go. Now it's a fire truck. Now my building. So, here's my building. It says that a 10-foot fire truck. So, and actually the building would not be lower than the fire truck. So there's my building. Now the fire truck is 10 feet. So we know the fire truck, which is this piece right here, is 10 feet. It parks beside a building such that the base of the ladder is 16 feet from the building. So, I'm going to use blue. Let's say the ladder is right here. And so it comes up. So, from the base of the building, so this is 16 feet. The fire truck extends the ladder 30 feet high. How high is the top of the ladder above the ground? So we have to find this distance. So we have a right triangle. We have to find that piece right there. So what side is that? A, B, or C? It could be A or B. I'm going to leave A squared alone. I'm going to plug in 16 for B because it's a leg, and then the hypotenuse is the longest side, which is across from the 90 degrees. So we plug that in for C. So now I take A squared, and A squared just comes down. 16 squared is 256, and 30 squared is 900. I solve the equation, so I subtract 256 from each side. That gives me 644. I take the square root of both sides, and approximately, since it's not a perfect square, this gives me about 25 or 25.4 feet. The problem is that 25.4 feet is just this. I'm going to color it in red. This piece is 25.4. I want to know the entire distance from the top of the ladder to the base. Well, you have to add on the 10 feet tall that the ladder or that the truck is. So you have to add 10 feet to the 25.4. So how high is the ladder above the ground? It is about, or approximately, 35.4 feet from the ground. The next thing we're going to talk about is an if-then statement. An if-then statement is called a conditional. Every conditional has two parts. The part following if is the hypothesis, and the part following then is the conclusion. So this is an example of a conditional. The entire thing is called a conditional. So this entire thing right here, this entire thing is called a conditional. It's an if-then statement. If an animal is a horse, then it has 4 legs. Now the beginning part is called the hypothesis. The ending part, which is after the then, is called the conclusion. So if we use that, that's the whole thing. I mean, it's a statement that's true. If an animal is a horse, then it has 4 legs. Now, the converse. This is what the converse does. The converse switches the hypothesis and the conclusion. So if I took this statement and switched these, I could say, if an animal has 4 legs, then it is a horse. I'll read it one more time. If an animal has 4 legs, then it's a horse. Is that true? It's not. So the converse is not always true. You can rewrite the Pythagorean theorem as an if-then statement. So I can say, if a triangle is a right triangle with legs of lengths A and B and a hypotenuse of C, then a squared plus b squared is c squared. The Pythagorean theorem, though, has a converse that's always true. This is important. This is your key concept. If a triangle has sides of lengths a, b, and c, and a squared plus b squared equals c squared, then the triangle is a right triangle. Here's all it says. I'll put this in easy terms. If you have a triangle with numbers and you plug it into the Pythagorean theorem and it works, the triangle is a right triangle. If you plug numbers in and it doesn't work, then it's not a right triangle. So example number 3. Determine whether the given lengths can be sides of a right triangle. So on number 3, 5 inches, 13 inches, and 12 inches. Are these the sides of a right triangle? So we have to plug them in. A squared plus b squared equals c squared. Now make sure the biggest side always gets plugged in for c. So we can do 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. That gives me 169 equals 169. That is true. So yes, this is a right triangle. Example number 4. 7 meters, 9 meters, and 12 meters. Do that yourself. Pause the video and see what you get. If you plugged it in, you'd have gotten 49 plus 81 equals 144. 49 plus 81 is 130. 130 does not equal 144. So no, this one is not a right triangle.